Hi friends, welcome to the Unit R Day 4. This is the factoring packet. This is a bonus sheet that we included with it. This really focuses on when we have 4-term factoring. What we're really going to focus on today is when you have more than 3 terms. So if you have 4 or more terms, there's 2 scenarios that you could have. One's called a factoring with 2 and 2, and then one's 3 and 1. So with our 2 and 2, so I'm going to just start off over here with this one. If I have these 4 terms, so 6n plus 10p plus 3mn plus 5pm, what we're looking for is we're going to try and group them in sets of 2. So if I group these in sets of 2, 6n plus 10p, this actually doesn't correspond to the next row. They're not written correctly. So off to the side, I'm going to go ahead and rewrite it. So this one is actually 6n plus, and then 3mn. So this actually gets us this right here. Now the next one, if I have then 10p and 5pm, that's what gets us this next set there. So when you factor out, you're looking to see, what do I have when I factor out? What's left in the parentheses must match exactly. If it doesn't match exactly, then it's not a factor. And the reason why we're doing that is, now that you have this factor of 2 plus m and 2 plus m in both, you can factor out the 2 plus m as a GCF, or as greatest common factor. So when you factor out that as a 2 plus m as that greatest common factor, what you have left then is 2 plus m in parentheses, and then the 3n plus 5p as parentheses. So it does not have to have any perfect squares or exponents, though it could. I really want to showcase that there may be some scenarios where you have maybe you have an m squared here as well. And then you might need to factor again. So I'm just bringing that to your attention that in some of these you'll have multiple factoring steps. I went through that one a little bit quick because I really want to focus on this 3 and 1. I feel like this is new for most students. With the 3 and 1, what you're looking at is you're looking at factoring them with a perfect square with 3, and then the last part is also a perfect square. So you have a perfect square and a perfect square. With this scenario, what you'll have is you'll have a difference of squares or a sum of squares here, and then a minus sign, and then a perfect square here. So it has to be in that scenario. When we do that, what we have is in this case, we factor out the difference of squares. So that gives us this part. And you notice that I've underlined this here. When we factor the x minus 4, remember we get x minus 4 and x plus 4. But to get the when we factor x minus 4 squared, we get x minus 4 and x minus 4. But to get this middle term being positive here and to work out with that negative here, we have one positive and one negative. So let's talk about the setup for this. So when we set up, we'll have your terms positive and then a factor, perfect square, and then your terms, and then minus, and then a perfect square. So you'll have 1 plus, 1 minus. This will be, in this case, this was the x minus 4 part, and then for this last part, this was the y. And then when we think about it when we get done, this is in the pattern of the a squared minus b squared. If you think about this part here and this part here as your a squared, and then b squared in this case is that y part. All right, so showcasing that specifically with these, I'm going to go through these examples in our next video.